Hello, in this video I want to introduce the idea or topic of responsiveness, and doing so, and as a gateway to kind of dealing with issues of responsiveness on the web, we're going to look at the CSS units. And so some will be a review and some will be introducing new ideas. So what is responsiveness? A responsive web design is the practice of responding to a user's behavior, screen, size, device, and orientation. A great example of responsiveness in action is the New York Times. So when this was designed, or the designers who worked on this, they have created code and styling that will ensure that this content will work on any device. So how we look at that is, if I go to my inspect here, I can go to this mode over here and it will show me what will happen as this page, how its width changes and how its aspect ratio changes. Okay. And so the designers have accommodated for, viewing this on a phone, viewing this on an iPad, looking at this horizontally, looking at it vertically. And that's the reality of designing things for the web, is we don't really know what device things are going to be viewed on. I mean, even if you do know, let's say, exactly the model of a computer, you don't necessarily know how big the windows are going to be. Or even more of a variable is what the user's inherent preferences are. Maybe they've done things to make the contrast higher. Maybe they've set the default type size to be bigger to aid in legibility. Maybe there's other factors. So responsiveness is designing and coding our websites to adapt to how the users are going to interact with them. So a good entry point into thinking about responsiveness and understanding how to make our designs responsive is to look at the CSS units themselves. So there's over 40 CSS units. The good news is, for the vast majority of the work we're going to do, we're only going to work with a handful of them, and we'll go through them one by one. They're broken down into absolute units and relative units, and I'll kind of explain that more as I go. But first and foremost is so what is a pixel? And it's not a simple answer. So a pixel, it depends on what context we're referring to. In a device, so on a screen or a television or a phone, the pixel refers to one unit of resolution, one little light bulb that has different combinations of red, green, and blue. In other contexts, for example, in things we create in Photoshop or renders we do in other software, a pixel is just an expression of a matrix, which is just a fancy way of saying a 2D grid of numbers. So it's pixel stores number values, and we could get into that some more, but basically, there's a red component, which is, it stores the red component, it stores the green component, it stores the blue component, and that makes up the image. And in that context versus the screen, in the screen there, the pixel takes up a set amount of space in the world, whereas a pixel, in terms of resolution and how we've been using it up to this point, there is no measurement for it. There's a resolution, but there's no real world measurement equivalent to it. Now, the CSS pixel is different than the pixel we've been using in Photoshop, because it actually behaves kind of like an inch or a centimeter. It's a little more sophisticated than that, but it has a real world dimension. So the definition of that is 96 pixels corresponds to 1 inch on a device from the predicted viewing distance. So what does that mean? If I take the exact same code and look at it on my phone or on my computer and measure it with a ruler, they are not the same size. They're close, but they're not the same size. But if I hold my phone and my computer at the distance I would view those squares while I'm working, they're actually the same size. And the reason for that is because of how our vision works. So this is a little diagram from Mozilla that shows, how this reality works, where the further away you are from something, the bigger the pixel needs to be for it to appear the same size as another device that you would be closer to. And all of this is encoded in the device specifications. And it actually, we'll look at this in class. It actually works pretty well. It's pretty amazing. But it's not just a standard unit of measurement. It's a unit of measurement that's based on viewing distance. So if pixels can be consistent and they're accommodating for different devices, why not just use a pixel for everything? And this is the first kind of consideration of responsive design, and it's because they don't scale. So one example of this is if we change the display settings, the browser default settings that the user sets, and we'll look at the kind of shortcoming of pixels. So in Chrome, if I go to my settings, and in my settings, I go to appearance, and then I go to font size, I can change this, and it will adapt to my preference. I can also just scrub over here. Now, if I set my type size in pixels, this wouldn't happen, which is where we'll introduce our next unit, the rem. So let's head over to VS Code for a second. Just reset this. And I'll introduce our next set of units, the rem, m, and ch. Okay, here I have a simple file, which we'll use to demonstrate these different units and the difference between pixels and rem. If I go to Chrome and I once again change my settings, put it over here to appearance, it is still responsive. If I go into my CSS though, and so what is happening? The units in the default HTML are set in rems, and rems are relative to the root HTML element. So what is set in the browser and in the preferences. If I define my own HTML, and let's say font size 16 pixels, and now we go over here. This isn't going to work because basically I've overridden the default preferences in my HTML. So then how do I set type sizes but still maintain that responsiveness for user preferences? And that is what the rem is for. So if I say h1 is 3 rem, all right, font size is 3 rem, it gets bigger, it's updating. But if I go over and change the preferences, it still works. So then the question is, what the heck is a rem? So the rem is relative to the root size. So if the root size, which is typically 16, you can kind of think about 16 as like a working unit. 3 rem would be 48, right? And 2 rem would be 32. We could, if we wanted to make the math easier and have our font sizes. So many developers work just right with rems and work with that base 16 and don't complicate things. But there is an option where you can take your HTML and you can say font size, and you can do a little math here. So if we say 10 divided by 16, we'd get 0.625. So we'll say 62.5%. And then what that'll do is the rem is now 10 points. So 3 rem would be 30 points, right? So I can show you if I made this, copy it, and made it 30 pixels, it's going to stay the same. Okay, so it's another layer of complication, but it might be an easier way to match an existing design. But the trick is we do not set type sizes in pixels anymore. We use rems. Therefore, if someone wants to override, it's still possible. Okay, so we set fonts in rems. So then what are ems? Ems are like rems, but ems look to the parent container for the size. So they're a little bit more complicated, and I would totally avoid them for this class, but let me just show you how they work. So if I said, let's turn this back on just to make the math a little easier. Okay, so my H1 is 30, and if I set my H2 to 2 ems, it would be the same as my H1. But where it gets a little crazy is if my H2, in this case, is a child of EM section. So let's grab that for a second. Section. And I set this to 2 ems. Now it's 10 times 2, which is 20, times 3 is 60, right? So now when we start defining stuff, you have this dependency on the parents, and it can get really crazy to determine what the sizes are. There are uses for ems when styling buttons and making layouts responsive, but for now, let's just work in rems, and it'll be responsive and it'll be much easier to work with. And you also have the option of using this HTML font size 62.5 so that your rems correspond to intuitive pixel value. So next, let's look at CH. So rems, ems, and CH are all relative units based on the font size. So I'll hide this for a second. I can say, if we want, P max width is 65 CH. And so CH stands for characters. So this is a really handy way of ensuring that the line length doesn't get so long that it starts to hinder legibility. And once again, this is a nice responsive unit. So if I make my font size on my P, rem, creeping this up a little bit, that line length stays consistent, which is great. It's super handy. Okay, so then the next group of units we'll look at as a set, and they are %FR and VH, VW, DVH, and DVW. So these units are all based on percentages, and the difference between the percent and the FR and the VH and DVH is the percent and FR are based on the parent container, whereas VH and VW are based on the viewport. A little bit like rems and ems. But in this case, we would prefer, or the majority of the time, you would use the parent sizing, and that will keep our layouts intuitive and responsive. So let me show you some of that. So let's clear all this out. Let's make it really simple. All that, and clear out all this. Okay, so we're gonna make a div, and we'll call this container. And in our container, we'll have another div. Whose class item. Okay, so two divs, super simple. Then we can start adding some styling to them. So we'll say dot container width is 50 VW. So VWs are percentage of the viewport, and we'll make the height also. We'll make the height 100 VH, and we'll set a background color so that we can see what's going on of pink. And there we go. And as we change the size of this window, it will always take up half the width and all of the height. And actually, to make this behave a little bit more intuitively, let's add a reset. Margin 0. Padding. Box. Okay, and now it's exactly the viewport width. And then in our item, we'll use percent. So let's say height. Actually, let's do width. Width is 50%. And we'll make this background color yellow. And let's set a height. Also 50%. Okay, so it's taking half the width and half the height and filling in the square. Why we wouldn't want to use VW in our child element is because it won't be responsive to the parent. It's basically breaking out of the flow and not responding to the parent container, right? So this VW and VH are the whole viewport, whereas percentages and FRs were fractional units, where we saw in CSS Grid, are relative to the container that the element is in. And then DVW and DVH are in situations where this doesn't work and it doesn't necessarily fit exactly in the page. So if, and I guess the greatest example of this is a phone, where there's other iOS or Android elements in the way, DVH is the device visible height, right? So it compensates for any of the iOS or Android things in the way. And it's actually probably a better default, but I don't really use it unless something's broken. Okay, so that's an overview of units. It starts to get us thinking about responsiveness. VH, VW, these are all responsive units. CH is a responsive unit. Pixels, we need pixels. They're great. They give us a lot of control, but there are situations, especially when we're dealing with typography, where we don't want to use pixels because we're going to be overriding people's preferences. And that was a monster video.